All right, to start this, I want to review the AH and K and how to graph absolute value equations. For this one, we'll do number 5, y equals the negative absolute value of x minus 1. Remember, the equation overall looks like this. A absolute value, x minus h. Not supposed to be curved lines. Something's wrong with my writing tools here. A straight line, because these are absolute values, plus k, where this guy is a liar, if you recall. This guy tells the truth. He shifts up or he shifts down. This guy shifts left or shifts right. And the A value is kind of like the slope, rate of change, rise and run, how fast things are going. So when I'm looking at this problem, number 5, I see the A value says negative. If there's no number there, I get to put a 1 in there. So this is actually negative 1. And you can turn that into a fraction just by putting it over 1. You can do that with any number. And so our rise is negative 1, which means down 1, and our run is positive 1. And then the h should be inside here, but I don't see any numbers inside here. That means that our h value is actually 0 when we don't see it. And then the k value is negative 1. That is the last value on the outside. Now remember, the vertex, I'll put V for vertex, is h comma k, which in this case is 0 comma negative 1. So I'm going to start with that. 0, negative 1 is right about there. And then from there, we want to go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1. And then remember, this is the axis of symmetry. That's where we'd fold it. So all these dots should be reflected on the other side and in the same place until we kind of see the V take shape. Remember, it's going to go off the screen. It's going to have arrows. It'll continue forever. Okay, let's do it again. Let's use A, H, and K to draw the picture down here for number... Well, if I can get it to go down. There we go, number 7. Let's try number 7. All right, so there's the A value. A is negative 2. Remember, we can turn that into a fraction by putting it over 1. So we're going down 2, right 1. Oh, you know what? This is a bad example for now. Let me give you one that's closer to what we talked about. Well, I don't see any that are closer to what we talked about. See. All right, so let's try these. Had a little more than the AH and K, and I want to keep it basic for you here. So I went and found this one. We'll do number 4. This is A equals, there's the A value, 3 to make it a fraction. Again, we'll just put it over 1. Here is the H value. It says x minus 4. Remember, it's a liar. If this says negative 4, then the H value is actually positive 4, and the K value is at the end. It tells the truth, so that would equal positive 1. Remember, HK, that's our vertex. I'll just write it above. So the coordinates for that are 4, comma 1. So I'm going to go find 4, 1, put a dot right there. There's where the V starts. This time it's a positive slope, so it's going to rise 3, 1, 2, 3, and then go over 1. I can only do it once because I'll be off the graph. But remember, here's the axis of symmetry, so there should be a reflection on the other side, and then we'll connect the V's. There you go. There's our V roughly. Let's do one more just so you have the hang of it. Yeah, I kind of like this one up here. This might happen time and again. Let's do problem number 2. Notice the A value doesn't look like it's there. Remember, you get to write a 1 in if you don't see it. So the A value is 1 over 1. The H value is lying to you. It says positive 1. We know it's really negative 1. And the K value is at the end. That is positive 4. So the vertex for this is negative 1. Whoops, that is not negative 1. Try that again. -1 comma 4. I was kind of mixing the two numbers in my head. -1, 4 is right about here. This is up 1 over 1, up 1 over 1, up 1 over 1. So the V goes off the screen. We could put arrows on it. We need a reflection right here over the axis of symmetry. So up 1 over 1 that way, up 1 over 1 that way. And we'll finish the V there. Okay, so now that you know how this works, we're going to change this to inequalities. We're going to use the same idea of A, H, and K, but this time we are going to change this to Y is greater than. Now, here's how I remember where to shade things, because there's going to be some shading. Greater is at the top, less is going to be at the bottom. And I always think of my piece of paper when I say greater at the top and less than at the bottom. If it's greater than, the shading is going to be above, up in here, or up in here, or if you mix the two things together, here's the left side, there's the right side, and so that kind of makes a V when you combine this guy with this guy. Less than is always shaded down here or down here. That's how I remember I color my paper. The second thing I want to tell you about, the reason I know this is greater than, Y is greater, is because I think of a bully. You know how a bully gets in your face and starts pointing their finger at you? And they think they're bigger than you are. So I always ask myself, who's bigger in this situation? Well, Y is doing the pointing. And so Y thinks he's the bully, he thinks he's bigger. He's pointing at all the other stuff, which is this absolute value stuff. So that's how I kind of remember this. If we were in person, I could really emphasize this better. It would make way more sense. But that's the best I can do with a screencast for now. All right, so Y is greater than. We're going to say A is 1, because we don't see it there, which is going to be 1 over 1. We're going to say that this is the H. It's lying, it says positive 1, so H is really -1. And then K is 4. So again, we're going to use the -1, 4 to go graph this. -1, 4 is there. Up 1 over 1, kind of the same thing we did a second ago. We've got the reflection. Now here's what we got to figure out when it's an inequality, when it's greater than. First off, does it have a line underneath it? I didn't draw a line underneath it. So if you don't have that, that means you're a dashed line. If you do have a line underneath it, you are a solid line. So that means this graph has to be a dashed line. It's not connected. The next thing we have to figure out is where to shade. We said if this is greater than, Y is doing the pointing, he's the bully, he thinks he's bigger, then the shading should be at the top of the paper. So if I come to shade this, I need it to be above the V at the top. And there's an absolute value inequality. Let's do it again, but this time let's do less than, and I'll do equal to. How did I know Y was less than? Because these guys are pointing at Y, so these guys are bigger than Y, which makes Y smaller, or Y is less than. He's being picked on, he's being bullied. Poor Y. Let's get rid of some of this nonsense. I need a bigger eraser so this goes faster. There we go. All right, A, H, and K. A equals, H equals, K equals. We're doing this one. A is right there. It's positive 3. How do you make it a fraction? You put it over 1. H says -4. We know that's lying. It's really positive 4. K is positive 1. That means the vertex is 4, -1. We're going to come to 4, -1, put the dot right there. We're going to rise 3, run 1. So up 1, 2, 3 over 1, up 1, 2, 3 over 1. We need a reflection, so up 3 over 1 the opposite way, up 3 over 1 the opposite way. All right, before I connect the dots, Does it have a line underneath it? It does. So what does that mean? Refer to this. If it has a line under it, it's a solid line. So we're going to go ahead and draw the solid line forever it goes. Draw the solid line forever it goes. Now, if y is smaller, if he's being picked on, that means we need all the shading to be at the bottom. So let me get a different color here. The shading is underneath the V. All the shading is where the solutions live. So I could pick any points underneath this V, any coordinates for those points, and they would all work. If I plugged them in, they'd all be solutions. Let's try it one more time. We'll do it to this one. We'll say less than, but this time no line. So the A value is 2. It's right there. Put it over 1. Rise 2, run 1. H is missing. That means it's 0. K is there. It's -2. So if we go to 0, -2, that's our vertex. And then we got to go up 2 over 1, up 2 over 1. You could do this all day long. Do it in both directions. Should be nice and symmetric. No line under this, so this is going to be a dashed line. And if it's less than, and I know it's less than because these guys again are picking on y, so y is smaller, he's being bullied. That again means shade underneath. So that's how you use the A, H, and K, the same as the equations, but this time to do the inequalities.